Hello, hello, good evening. Loud and clear at the back?
Yeah.
Cheers, thanks. Welcome to the May edition of the AWS News Group. It's awesome to see you all coming along. And I do know that the weather is a bit crazy out there, but we're very grateful that you guys showed up. Just to respect time, I'll be powering through this introduction. So let me just quickly jump to the agenda. Today, we'll be kicking off with Tomas. So Tomas is going to be talking about building GenAI apps with AWS and MongoDB Atlas. So Tomas is an advisory solutions architect at MongoDB, and then we'll be followed up with Sumit. Sumit is head of engineering at Lawpath, and he's going to be talking about transforming legal services with Amazon Bedrock. Pretty exciting stuff. So without further ado, Tomas, I'll hand over the podium to you. Thanks, guys.
Hey guys, how are you? My name is Tomas Arguinzones. I'm a solution architect for MongoDB based in Sydney. Hopefully you guys know a bit about MongoDB. If not, that's right. We're going to be talking about how to kind of use your data that might live in MongoDB, might not live in MongoDB, doesn't really matter, to kind of enrich or power that GenAI experience that pretty much everyone is talking about. So how do we kind of get in that mode and do things with it? With the agenda, we're going to be talking about vectors a lot, right? Like, so don't get scared. We're not going to talk about math too much, but vectors is what powers all that GenAI experience. So we're going to talk a bit about it. We're going to talk about use cases and integrations, how we can use vectors in order to power that GenAI. Just a couple of examples. And then workload requirements. Vectors are quite heavy and quite like heavy in terms of like how much they weigh and how much power they require to be processed. So how do we kind of balance that in order to get the best experience without having to fork a lot of money to do it? And then a couple of architectures around that vector search of how that works. Now, what are vectors? If you guys been around, you've been hearing about GenAI or AI in specific for a while now. What are those vectors that are going to power, in this case, that GenAI experience? We have here a bit of data. In this case, a bit of data is a piece of string, the text, a quick brown fox. It could be a PDF, it could be an audio file, it could be a piece of video. It doesn't really matter. It's just data. Whatever data we have, we can generate vectors. When we refer to vectors or embeddings, kind of similar. It's just kind of different words to represent the same. In this case, it's going to be an array of numbers. So what we're saying is that piece of string, our piece of data in this example, the embedding or the vector representation of that piece of data is this bunch of numbers there. That just the numbers itself don't say too much, but again, that's going to be very valuable later. What's key from here is we are saying is a very fast brown fox. It's not a dog, it's not a cat, it's not slow, it's quick, it's fast, it's very like high speed. So all the semantics around that little bit of phrase are incorporated in that bunch of numbers that we have in there. That's what's going to be very important, very key, because again, we're not doing a simple search. We're not replacing quick for fast. We're not saying brown or like a bit of dark, or we're not saying fox or a mammal. We're saying semantically, I want you to represent that piece of string or that piece of data into a vector, and that's that representation. It contains a lot more semantic and context around it. How do we get there? How do we generate vectors or embeddings from that piece of data? Our data, we're running through an embedding model. There's a bunch of embedding models out there. Very famously, OpenAI came with a bunch of them not too long ago. Now AWS obviously has a bunch of them, very powerful. GCP, Hugging Face, there's everyone out there is generating models. And this is going to be key because the models are very specific to the kind of data you are generating. So if you're working with generic data, when I say generic data, it might be generic text. That might be, you might have a plethora of options. But if you're working with medical data, for example, your models are a bit more reduced because not medical terms are very specific. So you need to work with a model that knows how to understand and weight those values. So we have our data, we run it through an embedding model, usually expressed as an API, and that embedding model will give us a vector. Again, we give a piece of text in this case, we run through an embedding model, it could be Titan, it could be Bedrock, it could be any other one out there, and we'll get an array of numbers that is going to be our vectors, our embeddings in this case. Now, why are vectors important? When we try to plot or represent our vectors in a very simplistic 2D chart, again, this is not a very realistic representation because vectors have many dimensions, multiple dimensions. So this is a very simplified way of doing it. But just to get an idea, when we plot them in there, we see that vectors that have similar semantics or similar meanings will kind of stay together. So we're putting two vectors in here, a man and a woman, and kind of like the vectors around it, representing, and we see that they're close. If we know where a man and a woman are, we know that they are similar, they're not the same, but they have a lot of similarity in terms of both are human, both are have a lot of things in common. So that's going to be key later when we try to do when we try to power that GenAI experience. Now, those relations between our vectors change based on the model we use to generate the embeddings, and also change based on the function we use to fetch the data. So we generate the embeddings, at some point later we might want to search that data. However we find that data, we search the data, we're going to use a function. And this is it gets a bit mathematical, but there's a few functions we'll talk about a bit later. That function or that type of function we use to search our embeddings will determine different results. What we're trying to say here is some models and some functions might say a man and a woman are closer than a man to a king, and a woman to a queen. But some other models might say, hey, you know what? A man is closer to a king than a woman is closer to a king. So what I'm trying to say here is many models, many representations. It's a market out there for the different models, and you can see online when you read the information that's coming out. Every single day there's a new model. Everyone's competing for this market because it's going to get very, very, very competitive. Now, generator vectors, what do we do with it? We search for it. If you can imagine, let's say it's Wikipedia. So you are generating vectors for the content of Wikipedia. I don't even know how many articles Wikipedia has. There's a lot of them. Millions, if not billions of articles out there for every single thing that everyone has thought about it. When we try to search through that documentation in a semantic way, and we'll explore that in a second, it's just a lot of data to search for. So if we try to do that in an effective or in a very high performance way, it's just going to be very expensive. So you're going to require a lot of compute in order to generate that or find that information. How do we get that? There is an algorithm that is KNN, so K nearest neighbor, that pretty much says, look, I'm going to find, based on a specific vector, let's say going back to this one, maybe man, I'm going to find whoever is around me. Because vectors tend to, if they look like each other, so say man and a woman or man and a king, they tend to cluster together. So if myself, I'm a vector, I am very similar to something else. When I try to plot them, I'm going to be very close to something that is similar to me. This KNN algorithm, what it's trying to do is, when you search for something, it's going to search for who is around you. Because that's going to mean what's semantically kind of similar to what you're looking for. Going back to the first example, if I'm looking for a quick brown fox, something that is similar to a quick brown fox is going to be clustered around it. So that search, that KNN, K nearest neighbor, is an algorithm, will help me find whoever is around me, and that's pretty much what I'm looking for, right? Give me anyone that is similar to a quick brown fox. Now, I said there's a bit of math. If you remember back in uni, there's a few functions to work with vectors. There's a Euclidean function, there's a cosine, and there's a dot product. This is kind of the mathematical representation of them. I'm not even going to stop in them because there's an actual function, a functionality we can use it for. So that's what we probably care about. We can use Euclidean for image similarity. If you think about images, every pixel potentially can change the context of the visual of an image. So in this case, changing a single pixel can change a total image. So Euclidean is very good for image comparison. Then you have cosine, where you have text concepts. That quick brown fox, very good for cosine. And then finally, dot product, it's very good for recommendation engines. You don't really know what you're looking for, you want something around that looks similar to it. If you want to go back to the mathematical bits, we can go back a bit later and I'll share this later with you guys. Now, KNN, that's the way we find whatever is clustered around us, and that's the way we should go. Problem is, when you get to millions or billions of vectors, it gets very expensive, even with a KNN algorithm. The way we actually accomplish an efficient way and results under seconds is with something called AHNSW, Highly Navigable Small Worlds. This is just a different algorithm that pretty much sacrifices precision for speed. It's going to say, hey, I'm still going to find whoever is around you, but I'm not going to be that picky with like precision who is exactly around you. So I'm going to give you results way faster, but I'm not going to be exactly that precise. That doesn't mean that it's not going to be precise. It's just going to mean you have to kind of fine-tune that maybe a bit more than with a KNN. But this is going to be way cheaper and way faster than if you have to traverse millions or billions of vectors just for a search. So this is what we're going to be using, at least in MongoDB. Now, why is this relevant? Because we are at a point of inflection on technology where like GPUs are still a bit expensive, but they're way more available and way more powerful than they used to be. If you could look back in time, we have around the year 2000, manual feature engineering. If you go a bit forward, we get like word betting or a bag of words. And then around the 2018, we get the transformers. That's when we start seeing the GPTs of the world, BERTs. Now large transformers, 3.5, ChatGPT, very familiar with them. And now we get the llamas, we get the GPTs, we get the ones embedded with Bedrock, and God knows what's after that, right? It's gonna keep changing a lot. So right now, we are at a point where we can actually work with all these algorithms that are quite heavy, quite resourceful, but we will not be able to use it back in a couple of decades ago. Now, Atlas Vector Search. This is more about MongoDB itself. Before that was a bit of theory. Atlas is the cloud version of MongoDB. So if you guys have used MongoDB in the past, I personally, before working from Mongo, used MongoDB a lot, but it was just in a container. Deploy a container, runs MongoDB, very easy to use. Not super resilient because as a single container goes down, I'm dead, but very simple to use. Atlas is the power of that like, in the cloud. Okay, supported also in obviously AWS and other regions that AWS offers. How does very simplistic architecture works? We have our client, whatever client that looks like, Python, Node, doesn't really matter. Vectors, we said before, is what powers all this GenAI experience. Vectors can only talk to vectors. So a vector only understands another vector, right? They cannot just plain text talk to vectors. You need to, whatever you're doing, you need to convert it to a vector first. So that's why we have that embedding model in there, because whatever we're doing, reading or writing, we have to run it through an embedding. Again, it doesn't really matter where that embedding lives, we have to run it through that embedding. It could be OpenAI, it could be Bedrock, it could be Gemini, it doesn't really matter. We generate our embeddings and then we put it into a database. That database has to be a very powerful database to run vectors. And we'll get there. MongoDB, if you guys are aware, is a document database. That means you store your data as documents. It's not relational. You can store data relationally if you want to, but you're not going to get the most power out of it. You structure your data into documents, very similar to how your object will look in your code. That's the way you push your data into MongoDB. The adding benefit of vectors inside MongoDB is, in this case you have on the left, an object that has an ID, it has a symbol, it has a quarter, a year, a bit of a structured data, whatever that structured data looks like. And it has a content, piece of text. What we did is we ran that piece of text through an embedding, and this is what we got. Right? This content embedding here. It's called content embedding. It could be called anything. Doesn't really matter the name. What matters is this is the actual vector representation of that piece of text there that says content. Right? We keep all that data together, structured data and vectors. Something changes on the structured data, the vector will be automatically updated. So you are not necessarily using or disconnecting or breaking that link between your data and your vectors. The reality is vectors are very powerful, but vectors rely on actual data. Without that actual data, we're not doing anything. So decoupling that or breaking that link means we have to put things in the middle, ETLs usually, to kind of keep that data in sync. That's another effort we have to put on top of it. In this example, everything is stored together as a single document, very flexible, very powerful, most likely atomic, in the sense of like something changes here, the content will be automatically embedded. We have, in the example of Wikipedia, millions, if not billions of documents in there, with a bunch of data, a bunch of content from all the Wikipedia articles. What do we do next? We create an index. In order to search the data, we need to create an index. This is an index that is a specific index for vectors. We have more indexes in MongoDB. This one is specific to navigate vectors. We're saying, hey, it's a vector index. This is the path where my field is. Could be anything, obviously, in that document. Number of dimensions, and this is going to be key in terms of precision. Like anything in life, more dimensions, more precision, but also more compute required to kind of work with it. So we always have to find that balance between what do we want to accomplish, how many dimensions we want to put, and how much money we want to pay for it. Because again, that involves more tokens in all those embeddings. And finally, what similarity function I want to use. Remember, for images, for text, or for recommendation engines. Create my index, index is created in the back end, and then finally, eventually, will be created. What's next? I create a query, or I start querying my data based on vectors. How do I do this? I do this running an aggregation pipeline. This is just a way of running queries in MongoDB. Very easy, very simplistic way of running queries. I'm saying, hey, I'm going to run a vector search, specific type of search. It's not a normal text, it's not a filter, it's a vector. I'm going to be working with vectors. I say the index, see here says query vector. That is my query parameter. At the beginning I say a quick brown fox. That was my search. That is the representation, the vector representation of my search. I say vectors only talk to vectors. So whatever I'm looking for, I need to vectorize it first. Run it to an embedding. So that's my query. Set my path. I set the number of candidates. Again, this is going to be key in terms of fine-tuning your search. Set a limit. This is going to be important also in order to guarantee that performance. And very important, I set a filter. Why is this filter important? Because let's say I want to find, I'm doing a recommendation engine with restaurants, maybe, based on the description of a restaurant. Well, like whatever people write some reviews. I say, hey, I want to find a restaurant that's very cool, very chic, very cozy. You know, like words that might not mean a lot for a lot of people, but depending on the target audience, it might mean a lot. But I don't want to. I only want to find restaurants in Sydney. I don't care about Melbourne. I'm right now in Sydney. If you give me results about Melbourne, I'm losing my time. I'm wasting my time in here. That filter is going to go back to. Oops, I went too far. The structured document that I have on the left, and you can filter data based on that information. So it's going to narrow down your experience a lot more before you start navigating those embeddings. The embeddings can say Melbourne, Sydney, it doesn't matter. I pre-filter, narrow my data before I start crunching data into those vectors. So again, it's very important because not a lot of databases for vectors offer you that capabilities. And again, it's going to make a difference in performance. Now, vector search, like I said before, is a capability that's offered on MongoDB Atlas, so that's the cloud offering on MongoDB. And it's just going to allow you to automatically synchronize your vectors, your embeddings, to power your GenAI with your structured data. A lot of companies out there, from banking, startups, doesn't really matter, they're using MongoDB for their data right now. Now with this GenAI wave, they're just going to start generating embeddings. If you go with a different solution, usually what happens is you end up with a separate product. So structured data, you might be using SQL Server or whatever you're using, like Aurora, RDS, doesn't really matter. But then that doesn't support vectors. So you have to go to a different product just for the vectors and somehow keep that data in sync. That takes time. that takes effort, that takes, more importantly, an ETL in the middle to keep people in sync. With this kind of option, you don't need an ETL. Everything is synced automatically because data is stored together, structured and vectors. Together with the power of the document model, with a unified interface, and more importantly, global multi-cloud. Most of our customers obviously run AWS, but if you want to run specific workloads somewhere else, you can. You are free to do that. And also super elastic and resilient. So again, it offers the benefits of multi-clouding with all the resilience and enterprise security that everyone should expect. How do we use this, more importantly? How do we actually power this to actually make sense for us? So a lot of people doing semantic search. So based on the meaning of the words, not actually on the specific word, because they can do full text search. Think about Elasticsearch or OpenSearch. That is based on synonyms and stuff like that. Semantic is more on the context of the words. So that's actually a lot more powerful. Question and answer systems, feature extraction, recommendation and scoring, synonym generation, image search, and more importantly, and this is where most of our customers are using it, for LLM memory and retrieval augmentation. Right? The famous, if you hear it, RAG kind of architecture. This is where we're going to spend a couple of more minutes. Problems with existing LLM models, right? Like, again, most famously ChatGPT. They have a training cutoff. So depending on what version of ChatGPT you're using, it's going to be trained into a specific point in time. ChatGPT 3.5 was September 2023, I think. And then if it's something that happens after that, it's just not going to know about it. So it has limitations. Also, it doesn't have access to private data. For a very good reason. I'm not saying it should. It doesn't have access to private data. So whatever your business does, it doesn't know about it unless it's publicly on your website. Again, very good reasons to do that, but that also limits and the kind of things we can do with ChatGPT. It's unfocused, and it kind of lacks suffers from hallucinations. So you might ask a question, and it might answer your customer data, your operations. Doesn't really matter. Whatever proprietary data you have in there, whatever product info, whatever order history, and even secure user data. Again, we're not saying expose it, but all that data is there. How do you use that data in order to power a GenAI experience? You want to jump in that boat. You don't want to open your doors for any leak. But how do you kind of match those two requirements in a secure way to kind of get the best experience for your internal use cases or also for your external use cases? This is kind of how the RAG architecture works, right? Same client we had before, Python, Node.js, doesn't really matter. That client is going to send a question, a quick brown fox for this example. That question is going to go to a framework. This framework is a new picture, a new entity we're introducing here. It's not a required framework, it's an open source framework, but that framework acts as an orchestrator. It sits in the middle and does a lot of different calls. We'll talk about them. You don't have to use them, they're open source, we don't obviously own them, but they actually work very well in making your life easier. What is that framework gonna do? First, it's gonna generate the embedding, transform that query into an embedding, and it's going to first search on your database, your private MongoDB database, with all your embeddings. Let's say it's your product catalog. It's whatever information you have internally that you would like to power a GenAI experience, you vectorize it. That framework is going to search internally in MongoDB on those vectors. It's going to get whatever finds, so whatever it's around, whatever is relevant in terms of semantic, and it's going to pass it back to an LLM. Think about ChatGPT is the most common of them, so we're going to use that for a reference. It's not going to just send the query, a quick brown fox. It's going to send also a bit of a prompt engineering that you all should do, obviously, and then a bit of that contextual data that it found internally in your database. For example, if I'm looking into a catalog, that catalog is private. That catalog might only be exposed in my database. It's not public in the internet. So that framework is going to search internally in my catalog something that looks like a quick brown fox in a semantic way. Whatever it finds, it's going to pass it to that LLM with the initial query and a bit of prompt engineering. ChatGPT, for the sake of the example, is going to kind of process that query with all the information, prompts, context data, and it's going to return an answer that the framework is going to clean up a bit and return back to the client. How is this relevant? Imagine a case where you have an image database, movies database. So very curated reviews of movies that is not out in the internet. So ChatGPT cannot scrap that content. If you ask ChatGPT about a specific movie that came out after September 2023, it will not know about it because it wasn't trained at 3.5 at least. With this kind of approach, if you have that very curated, database of movies, you can get insights of movies that came out after 2023. That information will be passed to an LLM, and LLM will provide an answer a bit more curated, less hallucinations because it has a lot more context based on your internal database to your end user. So again, it kind of powers that experience that we're kind of used to by now for the last year or so from the LLMs. It's going to just exponentially enhance it in terms of like the experience. This is a very fast-moving ecosystem. We said about those frameworks, so we have a couple of them. One is called Llama Index, another one is LangChain. They're just orchestrators. They talk to MongoDB and other databases. They talk to OpenAI, AWS, and GCP, and other providers out there like Hugging Face. They're just orchestrators sitting in the middle doing that communication. We obviously work very closely with AWS and the other providers. We are model agnostics. We don't care how you generate your embeddings. Just store them in the database and run with them. So you can generate your embeddings whenever you want. This is key because, like we said before, models are they're going to get quite specific. So if you marry to a model and then you find something later and you kind of change your model, that might be slowing you down. So you need to be able to adapt to whatever models come in the future. What are the challenges with vectors? Like I said before, navigating those vectors, millions or billions of vectors, can get very expensive, very slow, very quick. So how do we kind of do this? It doesn't matter how much we improve the algorithms, it's still gonna be a challenge, right? With MongoDB, especially since we're giving you the benefit of keeping your structured data together with your vectors, the reality is whenever you search for vectors, it's competing for resources for your transactional workloads. Imagine it's payments, your payment system is going through and writing a lot of payments, and then you have your vectors you might do for risk analysis or fraud detection. So you are competing resources because it's the same CPU, same memory in a distributed cluster. What can we do for this? We can do something with called scaling vector search with MongoDB Atlas. Pretty much, and I'll get to there how we do this in a second. What's a normal approach, or what a lot of people are doing out there? They have their transactional database, whatever that looks like, RDS, Postgres, MySQL, SQL Server, Oracle, doesn't really matter. That database is historically in charge of CRUD operations, change streams, like anything that looks like a transaction, and that's good. But then you need to introduce vectors into your platform, into your architecture. How do we do that? You introduce a specific vector database. The only thing that it does is vectors. It doesn't do anything else. At that point, you have a separated experience, and the only way to glue it together is with an ETL in the middle. Because somehow, vectors without data means nothing. So you need the raw data to generate the vectors. Again, it's just cumbersome because you have several platforms. What do we do with vector search? In MongoDB Atlas, we try to keep one technology, one platform, one query language. So the same query language require structured data and vectors, one infrastructure, no data duplication, and this is key. We're avoiding the same piece of data. You shouldn't be duplicating in 10 systems. You should keep it as one and duplicating data. It's not about the ETLs. It's also about if data falls out of sync, how do we fix that? So again, extra efforts we have to put in there. And more importantly, it's easier for developers. We want to make developers focus on developing that next application that's going to be a market leading. We don't want to make you manage technology, managing an ETL. No one is excited about managing an ETL, right? Everyone wants to be coding and developing that cool application. What we've seen is customers that go with MongoDB Atlas and vector search, 30 to 50% faster to market because it's just easier to get in. Easier to manage, you don't have to worry about infrastructure, it's all in there for you. Go from this, I'm not going to stop here too much, to this, a single application, a single database that handles structured data and vectors, again, all together. Like I said before, your data, whatever your data is, PDF, media, videos, data, text, it doesn't really matter. You still need that data because it's your main source of information. You're gonna generate your vectors, but if you decouple them, you have to worry about how do you keep them in sync. How do we work with scaling this? How do we make sure whenever you add that extra vector and that extra workload, that extra bit of weight into your application, your cluster, your MongoDB database cluster doesn't kind of fall apart, because at the end of the day, it is extra work. We have something called Atlas search nodes. So again, if you're not too familiar with MongoDB, you probably don't know this, but MongoDB is a distributed database that by default has, MongoDB Atlas at least has 3 nodes. So it's distributed across multiple availability zones in different regions if you need to. So a primary and multiple secondaries. One of the primaries goes down, the secondaries will pick up, no downtime, all beautiful. If you don't do anything, you can deploy MongoDB vectors in that database, and it will work fine. But it will compete with resources for your transactional workloads. What you can do is, and this is the bit at the bottom, you can deploy additional nodes. This is what we call search nodes. Those nodes will be only dedicated to working with vectors. All the data is automatically replicated. You don't have to worry about that. You don't have to worry about data falling out of sync or information vectors that are not relevant to your structured data anymore. It's all completely in sync automatically for you, but those, in this case, 2 search nodes at the bottom, will only deal with vectors. That means you are kind of decoupling your search. If it's something that only is relevant for vectors, it will go to those 2 search nodes. The rest of the transactionality of your systems, payments, whatever you're doing, still remains on the first 3. So fully reliable, fully highly available. You don't have to worry about it, but you are still powering that GenAI experience. Very easy. The other benefit is these 2 search nodes can scale independently. So if you need a bit more power, a bit more power in your database, you don't have to scale the whole thing. Imagine EC2 instances. If you need a bit more power, you scale to the next machine type, right? In this case, you can leave your transactional workloads, whatever machine type they are, whatever instance type they are, but then the search nodes, you can bump them up. So you can make them a bit more rough, a bit more powerful. It's kind of like an asymmetrical database that allows you to grow whatever you need. If you need more transactional, you grow on that side. If you grow more search, if you need more search, you grow on that side. All as a whole cluster. So a single connection string to do whatever type of operations you need in there. Questions? And I think I took a bit longer than expected.
Good question. So these embedded services, do you pass like an array of values like king, queen, princess, or to have the royalty kind of vector in systems?
You can have, that's a very good question. So MongoDB being a document model, you can have arrays and multiple levels of embedded documents inside it. But like, there's actually no limits. Whatever the structure of your documents look like, you probably don't want to generate an embedding on the whole document. You could, but it's going to be quite heavy and expensive on the tokens you're going to use. So you want to generate tokens on specific bits of information that are relevant for you. In that example I gave before, it was like I think it was like a stock market tick, and there was a content, and there was a piece of text. That's the only bit we're embedding. I could embed the whole thing. I don't really need to embed it. For my use case, I just embed that content. That's the string that I want to search. If I generate, I have a king, a queen, a princess, and like a loyalty, and they, in the context, in the semantics, it's known that they are all related to each other. And if it's not known in that text, there is some sort of data that you can model to say, this goes under this. So a queen is higher than a princess and that kind of stuff. When you pass that to the LLM based on the information that is contextually relevant, the LLM will figure out first the relationships, but also based on that contextual data that you pull out of MongoDB, it will give you a more accurate answer based on that, yeah. Any other questions?
Because the MongoDB solution stores both the model and vector data together, is there a way where we can apply data encryption features that MongoDB offers to the specific vector DB use case?
So MongoDB has things different encryption features, most famously like client-side encryption. So we don't know your key. You encrypt your data before it actually lands in MongoDB. So someone hacks your MongoDB database, they won't even access the data because we don't have the keys, they don't have the keys. So, but once you generate the embeddings are already a numeric representation. So there's no actually, at least not yet, a way to encrypt that embeddings. So also, the embeddings don't necessarily say what data is in there, if that makes sense. Those numbers we saw before, the array of big numbers, it just says, depending on the model you use to generate the embeddings, it just says, that little bit of number, it says, look, it's closer to a dog than it's closer to a cat, and how close it is, for example. But it doesn't say it is actually a fox. It just says, based on the semantics of the words, what do you kind of look like? So it's quite hard to actually figure out in reverse on the model and say, based on these embeddings, what were you actually saying before? So the reverse is quite hard to do at the moment.
Just to follow up on that one, so you can do client-side encryption of a document and then have the embedding stored. So you still can do a similarity search on all these encrypted documents. What does that mean?
So you can do standard search, like compound indexes, whatever standard database operations you do in whatever encrypted information you have. Yes, we have functionality for that. Once you generate the embeddings, like I said, those embeddings are not necessarily an accurate representation of your data. It's more like, what do you look like? But it doesn't say what you are. So
what's the client side encryption? Is like when you're querying data, you can send your decryption so that the search engine when you're encrypting data, they just look like stored keys, which is
yeah, again, it's a bit different to the vectors, but like with the client side field level encryption, the client, let's say your Python, Node, whatever application is, has a connection to MongoDB, obviously, because it has to write the data, but it also has a connection to, let's say, AWS KMS. So it actually exchanges keys with AWS, encrypts the data, and sends it already encrypted to MongoDB. By the time it arrives in the database, it's already encrypted. MongoDB doesn't know the keys, because, but we still have algorithms that if you enable it, you don't have to search all your data, but if you enable specific bits of your specific fields in your collections, you can say, I want to be able to search this encrypted data. We create some sort of tokens, and it's called queryable encryption. So you can still search data that is encrypted. A bit of a more limited search is like equality. We're now about to launch a range search on encrypted data, and maybe by the end of the year, substrings of encrypted data. But yeah.
You also have the similarity search.
Yeah.
Your embeddings are not part of it.
Correct. If you're embedding, you can embed in. You can generate embeddings of encrypted data, but I never tried, but it wouldn't probably make no sense.
Like the embedding is of the actual encrypted data.
Yeah.
The embedding is not. So
Correct.
the similarity search.
Yeah. You can. It's two different. You can mix them, like standard search with similarity search, or you can just do similarity search or whatever you need. You can mix because your data is all there. You decide which way you want to search it.
Sorry, we'll just leave the questions to the end if you don't mind, because just to respect the time.
Yeah, sorry about that.
If you don't mind, just ask the in the end. Thanks, Thomas. That was amazing.
Sorry, quickly. There is an event we're running. MongoDB Local is our like key event around the world. It's in July, in Sydney. So if you guys want, take a photo or later, just Google MongoDB Local Sydney. You find the event, register. It's free. You get a lot of experts in there. Thanks so much.
Fantastic. Thanks, guys.
Good evening, everyone. Thanks for coming to this meetup. My name is Sumit. Head of Engineering at Lawpath. So I'll be talking about how we are using GenAI to democratize legal at Lawpath. We were one of the first in Australia to use Amazon Bedrock service because the foundation models was in general preview, and we were given access to it to build a POC, and then we went to production with our proof of concept. So if you've been to my talk at the summit, I'll cover more other aspects of it. It's not the same, just a disclaimer. What we're trying to do at Lawpath is kind of build a good legal LLM stack. So before we delve into that, so the agenda is like, I'll talk about Lawpath, who we are, what we do, and then just briefly touch on how GenAI is changing the legal landscape. And then I'll briefly cover a use case we have at Lawpath, which we use on the daily. Just run through a high-level architecture of that and the learnings we had from there, so that you guys can probably take a few takeaways from there, and we'll go from there. So just to tag on to what Thomas just finished is like, I think the vendors like MongoDB are pushing the embedding and the vector search aspects of the stack, and we don't use MongoDB, but I think it's kind of like promising to see a lot of vendors kind of like innovating in that space. So what do we do at Lawpath? So say for instance you're a startup. Every startup needs two things. You need an accountant and a lawyer, right? So so you're starting a business, you have a startup great idea, you want to set up your company. So you can use Lawpath's incorporation service, company incorporation service. Your company will be registered in 5 minutes. You get all the documents needed to run your company, to be compliant. And then you're ready to hire your first employee. So on the Lawpath platform, we have templates, about 600 templates, all Lexis templates, which are legally compliant, to create documents. So you can create your employment agreement. And then now you have created your first agreement on the platform, and then you want it to be reviewed by a lawyer before you send it off. That's where we offer like legal advice service as well, as a legal advice as a subscription. So where you can get unlimited calls with lawyers, 30-minute calls, and you basically ask your questions related to your documents, which you just generated. But what we're really trying to do is kind of create like a tool set which does self-serve legal, where you can upload your document, ask questions about your document, ask about whether all the provisions exist, or any missing provisions, if the document is safe to send to the receiving party. So a recent Goldman Sachs report said that 44% of all legal work could be automated. So just word of caution that I don't think AI would ever replace lawyers, right? So the reason being is, look, like legal is very textual. So ripe for disruption, generative AI, LLMs, ripe for disruption. But it's based on precedents and legislation, which is constantly changing. So interpretations constantly change, law constantly changes. But in business and commercial law, which mostly Lawpath focuses on, most of these is codified. Like your NDAs, your contract agreements, or vendor agreements, or supplier agreements. They're all kind of like set in stone in a way, with few nuances based on your business and what you're trying to sell or what you're trying to do. That's again, for most part, I think AI can trawl through the data, trawl through all the legislation and precedents, and can give you a good answer based on what your document is or what your problem is. So what it's doing is helping lawyers accelerate their work, improve productivity. Before I go into what we do at Lawpath, that means it frees up a lot of time for the lawyers to focus on strategy and like real outcomes for the customers, rather than trawling through documents. That is where AI comes into picture. So on the Lawpath platform, when you book a consultation with a lawyer, or when you want quotes from a marketplace or a legal marketplace, you submit your brief, you upload a bunch of documents. So before GenAI was a thing, we had like legal assistants trawling through these documents, trying to like summarize a brief for the lawyers to look at so that they can help the client. That would take anywhere between a few weeks, right? That has been compressed to almost like a day or two now because of AI-powered contract reviews. So this is a use case I'm just talking about. So as I said, like for any legal question to be answered, these are the three main things you need. Sound reasoning. So with GenAI, that's what we got. So before GenAI, the thing which was lacking was reasoning. GenAI gave us reasoning. And then you should be able to, once you reason with a question, you should be able to say, okay, where your reasoning comes from. Then you quote the relevant material in the legislation or the law or any previous precedents. And then you have to take into account the user's nuances, like what kind of startup they are, what kind of business they're doing, what kind of product they're making, right? So that kind of ties back into all of this. So this is like a very high-level diagram of the GenAI use case. So as I said, like when a user submits a brief, which is, I want to review the employment agreement for the provided job description and make sure it all has all the provisions. And they upload a whole bunch of documents and say, this is the job description, this is my business, this is the agreement which I'm about to send. At this point, what happens is we take the user context, the user who has been using the platform, has interacted with the platform, has done documents, created a company so we know the industry they're in, the kind of business they have, and then we use the serve API. So most businesses have a domain name. So when they register, they provide their email address, which has a domain name. So with that, we can research what company they are through the serve API, get the data, establish the context of who this user is. So this is the end user for this use case is the lawyer, right? So the user has submitted a brief, and the serve API and historical data will establish the user context. And then you have the document extraction. So the documents uploaded, they get extracted, it gets embeddings are created, we upload it to the database, just like what Tomas covered. And then the next step, what happens is we take that context, we take all the and then we ask the worker to ask all the possible questions the user might ask the lawyer when they're on the call. At this point, what it does, it answers those questions based on, and it gets the context and the document extracts based on those questions, and then builds up a profile, a legal profile for that brief which has been requested by the user. And at the end, once all of that is done, the inference worker is then involved. The inference worker has a prompt. Yes, it says, you're working for a law firm as a paralegal, you have the task of drafting a legal brief. So I'll just go back to a really good quote recently. I think it's Andrew Karpathy. He said, the best programming the hottest programming language in town is English. So prompt engineering is all about how you can better structure a good prompt so that you get the right response from an LLM. So as you can see, you establish the context, you clear role play instructions to the LLM, provide the context, provide the legal context, and the relevant extracts, and send it off to the LLM. At this point, the LLM comes back with a legal brief, with what was the question, what was the executive summary, what kind of user is this, what business they run, what website they do, what do they sell, and what have they done on the platform before, and then the legal summary. So based on the question they asked, these are the relevant legislation you can refer to, these are the awards you can talk about, and all of that is in the legal summary. And at this point, when the lawyer looks at it, he has all the information to get started and take that call from the customer so all the due diligence is done, right? So we just replaced the paralegal. So paralegals do this. So every law firms hire tons and tons of interns and paralegals who trawl through documents, establish a brief for the lawyer, senior lawyer, to have a look. That all of this process is now reduced to a matter of maybe minutes. So it's a very high level architecture. So we use, as I said, we use Bedrock as our, that's where our foundation models are inferred. So the users talk to a consultation service, which then so we use EventBridge heavily. Most of the EventBridge emits events, and there are all these Lambda workers subscribe to these events. So we have a consultation service which publishes an event onto the event bus, and then the legal triage workflow gets triggered, creates a job in DynamoDB, and then the document worker does what it needs to do, the user context worker does what it needs to do, and then the fact aggregator then takes all this data, puts together, asks the questions, and establishes the brief. And then the inference worker does the final inference, posts the result back into DynamoDB, which is go back to the consultation service and the lawyer's consumer. So this is kind of like a very high-level architecture, very event-driven, using Bedrock and EventBridge and pretty much most of the cloud-native components in Amazon. So one of the biggest learnings we had, is picking the right foundation model. This is the first big challenge everybody will have, because in terms of, think of a foundation model as this, right? Think of it as a guy walking through the door, and you're going to interview for a job, for the role at your company. He's read everything possible. He's read all the legislation in the world. He's read every Wikipedia article possible. But once you say, oh, do you know who Lawpath is? And if they tell you exactly what Lawpath does, that is a big clue that that's the right foundation model for your business. So if the foundation model has already that truth grounded in it, you don't have to tell the foundation model then that, oh, this is what we do. So that kind of removes that layer of training that foundation model about you. And then at Lawpath, we've tried many things, but like Claude was the best possible foundation model because it's trained in specific domains, and it's much more disciplined when compared to the OpenAI suite of models, and then everything else. So Claude was the choice, and if you stuck with Claude, and since the proof of concept to what we're doing in production, we found that it's been validated, because what we do have at Lawpath is lawyers, right? So when the responses come back, we have an evaluation process where the lawyers can look at these results, and they say, okay, this is very close to the ground truth. You can then, what we do is then collect all of that data and do evaluations, and then measure against new models coming into market. But as you said, like, the use case is very important. Claude 3 is because of the context window. Claude 3 has a 200K token context window. That's a very large context window. Now they're like models with millions, but like, but I think for our use case, Claude works really well. And so far, we are happy with what Claude's doing for us. And then there's prompt chaining. This is another technique you can use where you don't have to have one prompt to send to LLM and get a result back. You can do screening. So first ask the LLM that, what is the context here? What is the user asking about? And then further filter it down. And you can use prompt chaining to establish guardrails as well. So if somebody is suddenly asking about, oh, what's happening with the volcanic eruption in Japan, and then it was like, oh, you're off topic now. So we are talking legal here. So guardrails will help keep the limitations, establish like a filter, the output, so deflects the user at the beginning of the chain, so that you don't have to use expensive models to answer very simple questions. And then RAG, as retrieval augmented generation, what Tomas touched on. So this is one thing which is very critical in terms of establishing context. When I said establishing user context, establishing document context, so when this worker, which is asking questions to the LLM, all the possible questions to the LLM, it's also getting all the possible chunks of documents which is relevant to that question. So when it establishes a brief for the lawyer to have a look at, the most important part is it needs to generate the right kind of results from the vector database and embed that in the right fashion. One of the issues with long context is this article is a really good article which says that in a lot of context, the LLMs lose context with the data in the middle. So you're really good at understanding what's at the beginning and what's at the end. It's just like when you read a novel. You really know when you first start reading the novel, you remember the pretext and it's all good. And at the end, you remember the ending as well. But what happened in the middle is a bit blurry. It's the same thing. So that's why models which use a long context, you really need to be able to lift your RAG game. So basically, use really good tools, tooling like what MongoDB offers, or use knowledge graphs. Knowledge graphs are really great. So have you ever used graph databases? It links things in a very programmatic fashion, right? So when the relationships are established, when the subject is established, it's very easy to get the LLM's attention on a large context. So this is an example, right? What is the zip code of capital China? So this is a subgraph which tells exactly how to navigate this information. And you can convert the knowledge graph to text and then knowledge graph text to LLM. So that at the end, it becomes like, it exactly knows what it's talking about based on that graph. So another thing is, there's new ways of doing RAG. There's this new technique called Raptor. That's a mouthful, so I'm not going to repeat all that. So Raptor is, what it does is clustering. So when you do a normal kind of like a RAG workflow where you chunk a document, put it in a vector database and do the retrieval, you get all the chunks you need, right? But what this does is goes a bit further. It establishes the same, like, as I said, the knowledge graph kind of like technique where this is a hierarchical tree, basically. It goes, okay, this is a source document, this is a summary, and this is a cluster of documents related to this summary. And then it groups them logically so that when the retrieval happens, the logical chunks are placed exactly where they need to be placed. And then evaluation. So this is the thing I talked about before, is that you need a really good evaluation framework to constantly measure the responses. So because, as I said, at Lawpath, we have the lawyers establishing the ground truth constantly. So what we are doing is building a really good database of responses small businesses have on a lot of questions and validated by a lawyer as a ground truth, right? So what happens with this evaluation is basically questions are asked and you provide questions, answers, context as like, so for all those questions, you provide all the relevant chunks of data related to that and the ground truth. So ground truth is like, okay, this is the actual fact. So when you create a big data set of this based on all the previous responses, and then you send it off to an evaluation, like for instance, in this example, it's using OpenAI, but it's the same applies to any LLM you use, it gives you a score from 0 to 1, based on like these few, when you evaluate, it gives you metrics based on all of this, right? So one is generation and retrieval. These are two different areas of your evaluation. You want to see how faithful the response is to the retrieved content from the vector database, how relevant the answer is to the original question, and then context relevance, right? So all the retrieved context, again, how relevant the context is to the query, and how well it aligns with the ground truth, and then how it's ranked, or is the context ranked properly from the vector database. So as you can see, the way you design, especially in the legal space, the way you design is you constantly establish precedents and ground truths. So basically ground truths is nothing but precedent. So as and when a question comes into Lawpath, and as and when a lawyer takes a call and finishes the call, they have established some ground truths about what certain questions and how certain questions should be answered. So those go back into our evaluation, and the next time Anthropic comes with Claude 4, we run the evaluation against it and see if it's any better than what we already had benchmarked, and if it is, we jump on to the next one. So this kind of like helps you understand the learnings which has taken place over the last 6 months. So as you can see, this space is evolving so quickly that every day feels like a month because tons of information out there, a lot of frameworks, a lot of open source work being done to improve all of the aspects of generative AI, like vector databases, and then evaluations, like Tomas mentioned, like the frameworks, orchestration frameworks like Llama Index and LangChain and all these different things. So they're all kind of like are providing evaluation frameworks as well. So the tool chain is really, really rapidly progressing and evolving. So that's where productizing legal comes. Now we have this experience of taking phone calls, establishing ground truth, checking all that back into the database, and kind of like rinse and repeat, right? So now, over time, we've been establishing a really good ground truth database for questions startups and small businesses might have about legal, commercial, startup law, and business law. So this is a very small space. We don't do criminal, we don't do civil, we don't do construction, because they're much more nuanced. It takes ages to get resolved. But a simple NDA is just very quick. But if even for a simple NDA, when they upload a lot of documents about, okay, this is party A, this is party B, this is what they do, this is what how do you establish the trust between them to share the information, and then the lawyers have to decipher that information and say, okay, this looks good, this combination of industries can work together. So anyway, so we have all that information, enough information to productize legal. And so that's why we have tools which like you can ask a question about anything about any general business and commercial law, and Lawpath AI normally refers back to these ground truths and answers this question. So this is only the beginning in terms of we're not saying that it is a perfect tool, but what we're trying to say is we want to create a tool where, because this is, Lawpath AI is free. So this is a completely non-commercial product on Lawpath based on ground truths which come from lawyers, right? So what we're trying to do is democratize law. So if you have a question about something, when you go on Lawpath, when you ask Lawpath AI, it's accurate most of the time. But again, we constantly get feedback, we constantly improve, and then because every business, as I said, is different. You kind of try and generalize and pull everybody in one bucket, but it's very, what we've noticed is it's very different. Every business has, there's new business models emerging all the time, and we have to cater for everything. And thank you.
Thanks a lot, Sumit and Thomas, for your presentations. I won't be taking much of your time though, but
just quickly, questions, Annie?
yeah. Questions for Sumit? I'm so sorry.
This is complicated. Yeah. Awesome presentation, by the way. That's great to see these AI companies in Australia doing some great work. I had a question about with your chat interface. Does it provide citations back to the actual source of truth?
Yeah, if it is a document review, it draws upon the clauses mentioned. It says, okay, this is what I'm saying because there is a clause 4.2. It states that so and so happened. So it draws back onto the document and tells you exactly which clause it's referring to.
Cool. So it's all right if it hallucinates a little bit. 1% of the time, because it's the user will always double check.
Yeah, well, because hallucinations will always happen,
Yeah.
and it's something if it's like the combination is quite nuanced and it strips it over, it will hallucinate. So we've seen that happen, but then we've also then rectified it, and then it goes back into more evaluation and see how that improves and what kind of context it needs before it gives the more answer which is closer to the ground truth.
So for the legal advice, does that have the regional restriction? Like different state have different law, right?
Yeah.
So how do you tackle that?
Yeah, because legal advice, it's based on when we draw on knowledge bases, that's looking at the corpus. So basically, every legislation.
What about a global company?
So we only cater for Australia and Australian territories and states. In the global context, not just yet.
So you can't earn their money then?
Sorry. We're trying. So it more kind of like every country, every territory has different laws, right? So in Australia we follow what we call this common law, and then every other common law country can use a similar framework, like for the UK, and even in the United States, like not all states have the same law. Like California has common law, but then other areas have case law, and it's quite different. So, and that's why like we have to kind of like master one area, and then look forward onto different things.
Thank you.
This is more like a PM question, product manager question. Is there any reason why you guys are offering this for free?
Usage. So one of the biggest studies we've done through a partner is that we've noticed that adoption of AI, consumption AI, is very low in Australia. It's still, people are very kind of like not sure what this AI thing is. So it will take time. So whatever usage we want, if we put behind a paywall, we're not going to get the usage. So it's always good for people to use it. And right now we are actually thinking to keep it free forever, because we think that that way we would be able to understand the needs of the customers better and then feed it back in making it better. It improves the model, basically how the whole framework works.
Yeah, just a very quick question on knowledge graphs. What AWS services are you using to store your knowledge graph? Is that in Neptune or are you using something else?
So we use Neo4j.
Yeah, just a quick question. I'm a lawyer myself, and I'd like to know what's the issue you have in paying lawyers for their work.
There is no issue, and we want lawyers to, because we at Lawpath have many really good lawyers, and we want them to get paid as well, and we rely on that as well as a revenue stream. So what it helps you do is actually make more money in a shorter span of time. So if you're able to troll through documents, able to summarize documents easily using the right AI tools, it helps you, like as I said, like it replaces paralegals who might take a lot of time to do the same thing and also probably might make mistakes. So the amount of mistakes made by using an LLM, which is a really mature LLM designed and trained on the legal domain, will help you get to the meat very quickly, meaning you interact with your client quickly, meaning you make more money. So it kind of helps with accelerating your productivity.
Thank you. Sorry, I was just joking. But I think the real question is, I was talking to some of my colleagues today, the main concern is privacy and how safe the data is. So if I'm asking a question using some information that has to be secure, what kind of measures do you have to protect the data?
Yeah. So there's when we put established ground truths and when we put the data into vector databases, databases and anywhere where we do retrieval, we do we make sure there's PII done, so it's personal information identification. So we de-identify a lot of data before it goes and becomes ground truth. So that way we don't expose it. And there's another reason why we use a large context model is because we want to make sure everything's transient, meaning like the context and everything is pretty much established near real time. So nothing's stored anywhere, so it's just retrieved, and then all happens in the context, and that context disappears once the question's been answered. So, and that's the main reason why we've chosen a context-based rather than a fine-tuning based approach. So, and then we found like going the fine-tuning part involves a lot more engineering, a lot more understanding of how weights and all that. Like we are more product engineers, so we're not like machine learning experts or whatever. We are helping build good products and trying to use the best tools we can as well. So as this space evolves, there's so much more information out there, so much more new technology out there. So it's really hard to keep up with that. So approach has to be initial approach has to be very conservative in terms of how you approach it, and less risk averse, especially to your point. Like user data is very critical, privacy concerns. So we try and make sure all like one of the biggest advantages of Bedrock as well is like it's kind of like sealed in your AWS ecosystem. That's why we don't use Anthropic's hosted model or OpenAI because it's outside our AWS ecosystem. So we kind of keep the data. So most of the data is it's in AWS within the account. So it's kind of like stays within the same window.
So I want to ask how do you treat the question about the law, because the law is very complex, especially
Yeah, so we don't train the LLM. The LLM is already trained. So LLM already knows, like, as I said, like legal is very textual, meaning all the legislations. There's a cutoff date for Quad 3 as well. But most of the legislation, most of the precedents is set. So that doesn't change. So most of these LLMs, because it's openly available data, that's the data they gravitate towards, because this is data produced by governing bodies like the courts and then the governments. So they are very much reliable, and the foundation models train on those data. So the established foundational knowledge is very much grounded.
Cool. Cool.
Maybe a silly question. Do you use any copyright content to train your model or report in your code? Do you pay for those copyright information?
What do you mean by copyright?
Like some maybe I'm not familiar with laws. It's not free to use, or you have to pay to get a copy. So I'm cybersecurity background. For example, we have a standard. We need to buy the ISO standard to use the standard.
Yeah.
Do you have to pay for those things? Or?
Yeah, we do. Like for instance, like the document templates which are created, like which are available on our platform, which users use, they're all licensed from LexisNexis. So we pay a license to LexisNexis for the templates. But these templates have a predefined structure. So, and then all you're doing is providing what your business is, what you're doing, what kind of information you're sharing with the other party, right? Yeah. But the core of the template is licensed data, which we then use that as a context to get the answer from the LLM.
Fantastic. Thanks a lot. I would actually encourage you guys to ask more further questions, but really appreciate your patience today. I hope that you found the presentation valuable. Also, yeah, we'll be seeing you next month again. For now, I'll just disperse you guys to enjoy your delicious pizzas. Thanks, guys. Take it easy. Do not forget forget to ask more questions, guys. These guys are waiting for you.
I do. I'm sorry. AWS.